Dear students of BSc courses, today we are going to discuss about borane and their types. Let me first discuss about what are boranes. Boranes are the binary compounds of boron and hydrogen. For example, B2H6, we call it diborane. B4H10, we call it tetraborane. B5H9, we call it pentaborane 9. The 9 means the number of hydrogen atom. Similarly, another one is B5H11. We call it pentaborane 11. This 11 means the number of hydrogen atoms. Let me now discuss about the bonding in boranes. Boranes are non-classically bonded compounds. William Lipscomb formulated 3 types of bonds involved in boranes. First type is BHB bonds. It is a 3-centered 2-electron bond. That means it contains 3 atoms but only 2 electrons. One electron is contributed by the hydrogen atom and the second electron is contributed any one of these 2 boron atoms. Another type of bond is BBB bond, that is boron-boron-boron bonds. It is also a type of 3-centered 2-electron bond. The 2 bonded electrons are contributed by any 2 of these 3 boron atoms. Third type of bond is 2-centered 2-electron bond. There are 2 types of 2-centered 2-electron bond. First type is boron-boron bond and the second type is boron-hydrogen bond. Let me now discuss about the structure of diborane. In diborane, the boron atom undergoes sp3 hybridization and form 4 hybrid orbitals. One of these 4 hybrid orbitals is vacant and the other 3 hybrid orbitals are singly filled. 2 of these singly filled hybrid orbitals undergoes overlapping with half-filled 1s orbital of 2 hydrogen atoms to form 2 BH bonds. The singly filled hybrid orbital of 1 boron atom, half-filled 1s orbital of hydrogen atom and vacant sp3 hybrid orbital of the other boron atom undergoes overlapping to form a boron-hydrogen-boron bond. It is a bridging bond. Okay. Thus, diborane contains 2 BHB bonds. This is one and this is second one, and 4 BH bonds. We may represent the structure like this. This one. The boron-hydrogen-boron bond, which is a type of bridging bond, may be called a banana bond. It is because it seems to be a banana. Thus, diborane contains 2 banana bonds and 4 BH bonds. Let me now discuss about the types of boranes. There are mainly 3 types of boranes. First one is closoborane. Closoborane means its structure is a regular polyhedron. All corners of the polyhedron is occupied by boron atom. For example, B6H6 2-. We may represent its general formula as BnHN2-. Second type of boranes is called nidoborane. Nidoboranes are formed when one corner of the polyhedra is removed. It is like a nest. It is non-closed and its general formula is represented by BnHN plus 4. For example, pentaborane 9 diborane, etc. The third type of borane is called arachnoborane. It is wave-like. It is also non-close borane and it is seemed to be a wave. Its general structure is represented as BnHn plus 6. For example, B4H10. Here n means 4 and 4 plus 6 equal to 10. Let me now discuss how we identify the different types of boranes as closo, nido, arachno, etc. There is a rule called Wade's rule. Using this rule, we may identify or we may classify different types of boranes as closoborane, nitroborane, arachnoborane, and hypoborane. How we classify? See the rules. According to these rules, we may represent the borane unit in such a way that it contains BH unit and negative charge and hydrogen atoms. According to this rule, each BH unit contributes 2 electrons to its skeletal structure. Each negative charge contributes 1 electron and each additional electron contributes 1 electron for the bonding of boranes. Now, after finding the total bonding electrons or total skeletal electrons, we may represent these total electrons in n plus 1 form, n plus 2 form, n plus 3 form, or n plus 4 form, where n means the number of boron atom. If the total number of electrons can be represented as n plus 1 pairs of electrons, then the structure will be closo. And if the total number of electrons can be represented as n plus 2 pairs, then the structure will be nido. Similarly, if it is n plus 3 pairs, then it is arachno, and if it contains n plus 4 number of bonding electron pairs, then its structure will be hypo. Let me now discuss some examples. First example is B6H62-. We may represent this B6H62- as this one, BH62-. Now, after representing B6H6 as BH whole 6, we get 6 BH unit in this compound. Now, using Wade's rule, we get 12 electrons which are contributed by 6 BH units. That is, 6 BH unit contributes 2 into 6 equal 12 electrons, and 2 negative charge contributes 2 into 1 equal 2 electrons. That is, total number of electron equal to 14, and we may represent this 14 number of electron as 6 plus 1 pairs, that is 7 pairs. Here it gives n plus 1 forms where n equal to 6, hence the structure will be closo. Similarly, in case of B5H9, we may represent this compound as this one, BH whole 5 H4. Now, after representing in this type, we get 5 BH unit and 5 hydrogen atoms in this compound. These 5 hydrogen units, these 5 BH units contributes 5 into 2 equal 10 electrons, and 4 hydrogen atoms contribute 1 into 4 equal 4 electron. Thus the total number of bonding electrons here equal 14. Now this 14 electron can be represented as 5 plus 2 pairs, that is n plus 2 pairs. Here n means 5, the number of boron. Hence the structure will be nido. Now let me calculate the number of bonding electrons in B5H11, pentaborane 11. Pentaboron 11 can be represented in this type BS5H6. That means it contains 5 BS unit and 6 hydrogen atoms. 5 BS unit contributes 10 electrons, that is 5 into 2, and 6 hydrogen atoms contributes 6 into 1, that is 6 electron. Thus the total number of electron equal 16 or 8 pairs. 8 pair means 5 plus 3 pairs, that is n plus 3 pairs. Hence the structure is arachno. Thank you.